Hello friends, I am Subhrajit Assistant Professor in Nursery Engineering College. So today topic in this session I am going to discuss algorithm versus flowchart. No doubt it is a very easy topic, but still some knowledge in depth everybody should have about this algorithm and flowcharts. I will start from the history and I will tell the difference between what is the algorithm and flowcharts. And finally, I'll try to solve some numericals, some problems based on uh, how to solve with the algorithms and how the same problem can be solved with the flowcharts. And finally, we will do one comparisons between the algorithm and flowcharts. Which one is the good, which one is the bad, right? Like this. This algorithm concept, it is not a new at all. It is a very oldest technology, oldest method, right? In the 8th century, this algorithm concept implemented, right? Who implemented? The father of algorithms generally, Muhammad Khawarizm, right? Muhammad Khawarizm is the father of algorithms, right? What he told, generally in the earlier days, the algorithms is designed for solving of mathematical problems, mathematics. But right now, nowadays, mathematical related problem also we are solving. Addition to that, huge amount of its application widely used in computer science. Okay, computer science. Any program you are designing, in that case, this algorithm concept mostly used. Apart from that, artificial intelligence, right? Algorithm concept is used. Okay, big data, algorithm concept is used, right? Even if in our day-to-day life, in our home kitchen also, we are using the algorithm concept, but we don't unknowingly. My my father, my mother, everybody in our day-to-day life is doing algorithm concept. General examples: preparation of any recipes, preparation of coffee, teas, everywhere. Some step-by-step procedure is available, is involved. That is nothing but set of rules. That is nothing but set of steps we have to follow to prepare any dish or any recipe, any food items, right? So those step-by-step rules is nothing but algorithms, right? Even if it is a mathematics problem also, certain step we have to follow to find out a solutions. So while this concept introduced, they have kept some characteristics, right? Characteristics. If any procedure is following these listed characteristics, then we can say that procedure, step-by-step procedure, is called as an algorithm. Right? What are those procedures, sir? What are those steps, sir? First step is the algorithm steps should not be or should be unambiguous. Unambiguous. Ambiguous. That means it should not confusing. No confusion should be there. Clear procedure, clear steps should be there to find out the solutions. Second one is what? Second one is input. Okay? Input. An algorithms may need input, one input, multiple input, or may not need also no inputs, right? It may require either input or may not need, right? Some mathematical problems or some logical cases will be there where input is not required. But most of the cases, input is required. Right. Next is what? Output. Output. My algorithm, what I have designed, that must be give at least one output. At least one output. It may give multiple outputs, but at least one output should be expected from that algorithm. Right. What is the next one, sir? Next one is it should be contain finite number of steps. Finite number of steps. Finite number of steps means anybody should get a solutions in a countable number of procedure, countable number of steps. It should not be infinite. It should be end. The algorithm should be end. It should not be infinite. So it should have finite number of steps, or we can say finiteness. Property is called, characteristics is called finiteness. Right. Next one is language independent. Language independent. That means to design an algorithms, there should not be any specific language. Any language human can understand, they can design. So like this, several characteristics are available. Few are most important. These are most important, what I told. Finally, if it is my algorithms, if it is my algorithm, if I'll give some input to the algorithms, then I should get one output. Right. So here step by step procedure should be written. So any input I will give as per the requirement, then I should get one output. So this is the some basic points about the algorithms, right? I hope you understand. I will solve some example also, but before that, let me tell you what is flowcharts, right? And one more thing here. Here, how to write the algorithms? How to write? We have to write like this: step 1, step 2, step 3, like this step n after it. And the parameters, what is we are writing here, all are text format only. Text format, right? Text format in the algorithms. Every lines contain some text format or expressions, right? Expressions also we will find. So in this way, we are going to write the algorithms step by step format. Now coming to the flowchart. What is the flowchart, sir? Flowchart. This concept came 19th century, 1921 around. And this concept is given by ASME, American Standard Mechanical Engineering. American Standard for Mechanical Engineering. Actually, this concept of flowchart, they are using in the beginning in the manufacturing industries. Manufacturing industries. For what purpose, sir? For manufacturing industries, for flow process of a product. Okay, of a product. That means raw materials will be there. The raw material will be flow step by step, and finally I will get a final product. So to convert the raw material into a final product, they are using the flowcharts. diagrammatically, they're using how my raw material will be converted to a final product, what are the process will be involved, what are the several condition parameters has to be involved. Based on that, they are preparing this flowcharts. It is a concept in the year of 1921, introduced by this American standard of American Society of Mechanical Engineering, not standard, American Society of Mechanical Engineering, right? Sir, what is the difference here? No, algorithms and flowcharts both are similar. Both are similar. What is the difference, sir? In algorithms, everything we are writing in text format or in expression format. We are using sometimes some expression also, expression. But in flowchart, everything is graphical representations. Graphical representations, or we can say diagrammatical representation. Diagrammatical representations. Right? This is the difference. No doubt, whatever the steps we are mentioning in the algorithms, those steps we are converting into graphical format or diagrammatical format. Same procedures, but representation style is different. Sir, why they have do like this? Because text format, expression format, very difficult to write. Very difficult to write and very difficult to understand, very difficult to read also. But if it is in graphical format, some pictorial format, it is eye-catching, right? Everybody will take interest to look at this one. And sometimes in the algorithms, few steps it is skipped. Few steps. Sometimes, some cases, 1 to 2% cases, few times, some steps is skipped, but because it's very difficult to represent those steps, that's why they are skipping the steps. But in the flowchart, as it is a very easy way to represent a solution for a particular problems, everything available in details here. Everything is available in details comparison to algorithms. That's right. Sir, how to design or how to develop a flowcharts? To develop a flowcharts, they took help of some geometrical parameters. Geometrical parameters. Okay. Geometrical parameters. So what is flowchart? Flowchart is the graphical representations or diagrammatical representations of a solution of any problem, right? And to represent the solution in flowcharts, they have taken the help of some geometrical parameters. I mean, some geometrical shape figures. What are those figures? Simple. Observe carefully here. Here is the symbols. First one is what? Arrow mark. It represents flow lines. Your process is flowing top to bottom, and in between, based on the requirement, it may flow towards right, towards left also. So this arrow mark clearly indicate in which direction your process is flowing to get final output. So this is the use of arrow mark, right? It's a geometrical figure, right? This one is one more geometrical parameters. You can say it is oval set, right? It is used to represent the starting point and ending point of a flowcharts. I will show you example, don't worry, right? Next one, coming to next one. is a parallelograms, right? It is a parallelograms. I told algorithm needs some input, may need some input, and it will give some output. So in the flowchart, to give input and to display the output, we are taking the help of this geometrical parameter, which is nothing but parallelograms, right? Parallelogram. Suppose in the summation of two numbers, I need to read two values. So I can write the two values in this inside this parallelogram. So input I have to give, input represented and output represented by this parallelogram, geometrical shapes. Now coming to this one, it is a rectangular shape. For what purpose? So to solve a particular problem, I need some variable declarations. I need some mathematical formula for calculations. So those formula, those declarations, I have to write inside this rectangular shape box. Okay, here is used for arithmetic operations and data manipulations, clearly written here, right? 1 minute. Okay, now this is a diamond shape. This one is the diamond shape, right? I told while your process is flowing from top to bottom, in between it is required you may go to left side or right side based on your decision conditions. So whenever some decision taking steps will come or condition related steps will come, in that case those decision taking steps or condition steps we will write in this diamond cell. Then it will be give one output, sorry, more than one output. It may give more than one branch, maybe right side, left side, or below also. More than one branch will come. Decision, either you go left side, either will go right side, either will go bottom. So in that case, in that situations, we have to use this kind of box to represent this kind of geometrical shape to represent any decision making statements or decision making steps, right? Now coming to the next one, this is a circular shape, right? What is the use? Use is to connect, used for the connection purpose. Connection purpose means suppose in the decision making you went to right side and you went to left side and finally you have to come back. You have to come back and finally you have to display the result, right? You have to display the result. So when you will come back, you have to join somewhere first. You have to join somewhere first. Then you have to join through these circular sections. I will tell you here, don't worry. Suppose in the decision making statement, you went left side and you went right side based on the conditions. Then finally you have to come back once again, right? You have to come back once again. So how to come back here? Here you have to do circular section so that connections. Then further proceed here. Again further proceed. So it is used for connecting the parameters in the same flowcharts, right? Now coming to next one. This one is what? Off-page connector. Off-page connector means suppose your flowchart is not completed in one page, some part is available in the second page, then page-to-page connection is done by this symbol, right? Okay. And finally, these diagrams, it is used to represent the group of statement performing one processing task, right? So these are the several geometrical parameters we are going to use for this, to solve a problem using the flowchart process. Let us discuss one problem here. What is the problem means? Suppose I want to find out the square root of a polynomial equations, quadratic equation. Square root of a quadratic equations. And you know quadratic equation format is like this: ax square plus bx plus c equal to 0. Right? If the same thing I will process, try to solve by the using algorithms, then sir, what will be my step-by-step procedure to find out the roots, not square roots, roots of a quadratic equations, right? What is the step one? Step one. What is the step one? To find out the solution, I need a value, b value, and c value. So right here, read or input a, b, and c values. After that, formula for find out the root one. Root one is, or formula is minus b plus minus b square minus 4ac root over divided by 2a. This b square minus 4ac is called discriminant. Okay. So I have to find, since square root is there, so this part calculations most important. It will change your result. It will change. It will give different types of results based on this part calculations. Your result depends upon different solutions, right? What are those? Then first you have to calculate the discriminant. Calculate or find, you can write the discriminant. Generally it is denoted by the symbol d, and what is the value, sir? B square minus 4ac. And step 2 is over. Now suppose the d value, if d value is greater than 0, this d value is greater than 0. Greater than 0 means, suppose d value came 8 or 9 or 12 or 122, like this, greater than 0, not equal to 0 or not less than 0. Then what will be happen? What answer I will get? R1 become minus b plus root over of d divided by 2a, and one more, R2 become minus b minus root over of d, because d value is already calculated here, b square minus 4ac, and the b value is positive, greater than 0, divided by 2a. And this is called real root. Real and unequal, because R1 value is different, R2 value is different, and these are real roots. I mean, it may come some positive numbers or negative numbers. These are real numbers, right? Another case will come. What is the another case? Else if d equal to 0, suppose. Okay, d equal to 0. D equal to 0 means, then I have to find d root over, right? Because d value is b square minus 4ac, root over is there. So d root over I have to find it. D root over I have to find it, right? So 0 root over is how much? 0, right? If d equal to 0, then this total part become 0. Then what is the result, sir? Then R1 and R2 both become equal and value become minus b by 2a only, right? This part becomes 0, only minus b by 2a only. So this kind of answer solution is called real and equal. Real and equal. Another case also there. What is the another case, sir? Else d less than 0. Okay, d less than 0. That means this value will come less than 0. Less than 0 means minus 2, minus 8, minus 122. Like this value will come. If you find out the root over of a minus value, it will give imaginary value. It will give imaginary value in that case. So if d less than equal to 0, then what is my R1 value, sir? 1 minute. What is my R1 value? R1 become minus B plus root over of minus D, minus D by 2A. And R2 become minus B minus root over of minus D by 2A. What type of solution it is? It is imaginary solution. Imaginary. So like this, several three situations may came based on this D values, right? D values. And finally, what I will do? Finally, what I will do? I will declare the result. Okay. What I will do, sir? Step next. This is suppose step 1, 2, 3. Okay, 3. Step 4. Step 4. Step 4 will display R1 and R2 value, right? Display. Step 5 is what? End. It is end. Right? This is the algorithm for find out the root of a quadratic equations. Now, same quadratic equations I will solve by the flowcharts. Observe carefully. Right? Observe carefully some diagrammatical representations. So to give some diagrammatical representations, I have to use some geometrical parameters, right? Just right, geometrical parameters. First one is oval shape. I told you, oval shape. Here I will write start. Start. Right? Then arrow mark is required. So use the arrow mark, flow lines, right? Arrow marks. 1 minute. Right? Arrow mark is required. Next, quadratic equation, right? Same quadratic equation root I will find. Sir, I need A value, B value, and C value, and I have to calculate D also, right? D also. Then variable is required. Variable declaration is required. For variable declaration, which blocks are processing, right? We are using rectangular box, right? In that rectangular box, you write take variable or declare variable A, B, C, and capital D for discriminant. Capital D for discriminant. And also root for root result, one root is R1, another is R2. Another is R2. R1 and R2. And you can also take imaginary part, a real part, optional. As per your flexibility, you can take number of variables, no problems. If you take more clarity, you will get, right? Next is what? Next is again flow lines, right? Again flow lines. Next, after this one, I have to read the value. For read the value, which blocks are required? For read the value, parallelogram is required, right? Parallelogram is required, but here parallelogram is not there. Parallelogram is required, right? Okay. Right? Like this, parallelogram is required here. In that parallelogram, what I will write? I have to give input. What input requires? Simple. I have to read A value, B value, and C value. Okay, A value, B value, and C value. I have to read. After reading A and B and C value, I have to calculate D. I have to calculate D. For calculation of D, that is a processing, right? Which block is required, sir? Again, rectangular block is required. Rectangular block is required. So connect this one with arrow mark. Here, right? What do you want to calculate, sir? You want to calculate D value, and D formula is B square minus 4AC, right? B square minus 4AC. Okay, now as we seen in the algorithms, it can give 3 result. See, in the algorithms, to write this kind of sections, very difficult. This kind of sections very difficult. D greater than 0. A lot of confusions will be here because it written in some expression is written, some statement text is written. Very difficult to understand. But in the flow charts, it will give very good clarity here. Observe carefully. What is this one? Then flow line give. Flow line give. I will start from here. My space is not there. It starts from here. Decision making now come. Decision making always diamond shape. Diamond shape. Arrow mark is ended here and start here. Diamond shape. What I will write inside it? I will write check D greater than equal to 0. Right? This D value, what will be answer come here? D value, check it is greater than equal to 0. If it is greater than equal to 0, that means if it is true, suppose D value came 8. 8 is greater than equal to 0, that means true. Then go to left side or right side, your wish. If it is true, right? True. Suppose D value is came minus 8, that means less than 0. That means this condition not satisfied, not true. Then go to left side. What I will write in the left side, right side, you will see. But first, this is the concept. This is the two cases will come. If D will greater than 0, go left. Less than 0, go right. Right. Now, if it is true, D greater than 0, then what is my solution, sir? Solution is very simple. And result always written inside the square box, right? Let me do a little bit big. Okay. Now, R1 equal to minus B plus root over of D divided by 2A, and one more root is what? R2 equal to, already R1 R2 I have declared here, right? R1 R2 equal to minus B minus root over of D divided by 2, which is a real root will come, right? Right. Okay. Next, now arrow mark you have to give like this. Arrow mark you have to give flow directions. Now suppose it is false. Condition is false. Then go to right part. Right part also like this root. False. If false, then root is imaginary. Then find out the real part and imaginary part first. You know, imaginary number, how it is represented? Imaginary number A plus JB. Like this in this format. This is called real part. This is called imaginary part. Right? So you write here real part first. Real part for I have taken RP and IP. RP become, what is the RP becomes? Formula is what? Formula is minus B plus minus B square minus 4AC root over by 2A, right? This is real part, and this value less than 0 means my negative. So this is become imaginary part, right? So real part become here minus B by 2A minus b by 2a, and imaginary part ip become root over of minus d, because negative na, d value is negative, minus d by 2a by 2a. If it is so, then what is the r1 value, sir? r1 equal to which format we are representing the imaginary number? Like this na, real part plus j into imaginary part, like this, right? Real part is rp plus j into imaginary part, and r2 equal to rp minus j into imaginary part, like this. So this should be also kept in rectangular box, and you have to connect this one with what? Arrow mark, right? Arrow mark, connect like this, arrow mark, right? And this one also you joined with the arrow mark. Blue color line I'm using for arrow mark, right? Okay. Finally, I have to declare the result, right? R1 and R2 value. Now I am in left side, right side. How to connect? I told circular section has to be used. Right, circular section has to be used. Then come here to here. Come here to here. If it is true, then this is your answer. This one is your answer. If it is false, then this one is your answer. Right? Then finally, what we will do? Finally, display the result, display the R1 and R2 value. For output, right? For output purpose, which blocks are? Again, parallelogram, right? I don't have parallelogram, that's the problem. Parallelogram. I have to use the parallelograms. I will make it parallelogram first. Like this, you have to make. Here, what will write? Display R1 and R2 value. And after that, again, arrow mark will be there. Arrow mark will be there. And finally, what? Finally, once again, oval shape will come. After this one, after this arrow mark, oval shape will come. And here, you have to write stop. Right, stop. So this is a question I solved. How to write the algorithm for this quadratic equation, find out the root, and how to solve the same problem by using the flowchart. So I hope the concept is understanding. Now let me list out what are the several advantages or comparisons we will do in between these two. So comparison means question will come. What is the difference between algorithms and flowcharts? Right? Flowcharts. Sir, what is the point, sir, here? Algorithms. It is a step-by-step procedures, right? Step-by-step procedure. It is a graphical representation. Step-by-step representations. It is a graphical representation or diagrammatical representations. What is the next one? It is in text format. It is in text format. It is in here some geometrical parameters used to represent. Geometrical parameters involved here. Right? What is the next one, sir? Here execution is difficult. Execution is difficult, but here execution is easy. Execution is easy, right? Execution is easy here. And what are the next advantages or comparisons here? We can write here. Here, difficult or complex problems, understanding the difficult and complex problem is complicated, right? Difficulty to solve or difficult to write the algorithm steps for a complex problems. but it is easy way we can write. Complex or very difficult problems we can write in the easy way. Second one is here, next one is here, the confusion will come when some decision making part will come, decision making section or part will come, but here no confusion. Just I show you here, this is a decision making part, and here something, if anybody will see, he will confuse. If new to this algorithm, he will confuse, but here easily diagrammatically I have represented, little bit knowledge also he can feel very comfortable to understand this one, right? That much comparisons or differences there. So these are the several points about the algorithm and flowcharts. Right? You can solve the next problem. Suppose find or check the number is prime or not. Right? Prime or not. You can list out the algorithms and you can list out the flowcharts. But not in this video. The next time I will discuss this topic. So till then, take care and bye.